So you should think about how I might ask other questions. I might well ask you a question to show that this is the case. If the, give you the base, give you the height, ask you to construct this and show that the area of the rectangle, let's say, is equal to the base of the triangle times the altitude. All kinds of questions I can ask. I can ask for a airtight explanation of why this side is parallel to this side. I mentioned it here. You should understand that. And of course, I emphasize the way to be prepared for a test on this material is to have done the assigned problems and read the assigned sections, because there are things in the section that we haven't talked about in class. For example, the simple curves. Very easy concept. If you read the chapter and did the problems, you would understand it. Okay, now this is a little more complicated, so you have to understand things a little more deeply to be able to do this, but people did well with this in class, and I expect that people will do well with it on the test. Okay, problem 11, we're asked to construct two copies of a scalene triangle into a parallelogram. Okay, well, here's a picture, and we'll talk about it in a minute. Let's first talk about the fact that you need to know what a scalene triangle is, an isosceles triangle, an equilateral triangle. A scalene triangle is one whose three sides are all different. Isosceles, two of the sides are the same. Equilateral, all three sides are the same. And you also need to know what a right triangle is. I think you know that. There's one right there. Or an obtuse or an acute triangle. Okay, obtuse triangle, your angle is bigger than a right angle. Acute triangle, all the angles are smaller than right angles. So this is a scalene triangle that also happens to be acute. I take two copies of this triangle, put them together like this. This angle is the same as this angle if I have two copies of the same triangle, because this angle lies between these two sides and this angle lies between the two corresponding sides up here, making this side parallel to this side so that we have two parallel sides. And we can also make a very similar argument showing that this side has to be parallel to this side. So there's a parallelogram, and then we go ahead and I don't know that the problem asked for it, but as a bonus, we go ahead and see how to construct the parallelogram into a circle. We simply cut it here, take this triangle, turn it upside down, paste it over here. So just to make that even a little clearer, okay, we've taken this triangle here, which I'll shade, and put it over here, and I'll shade it over here. Okay, well, just a couple of other things, little bonus. If this is the base, regarded as the base of your triangle, and this is an altitude, and you remember that an altitude goes from a vertex to the base at a right angle, so the altitude would have to be at a right angle, and let's go ahead and indicate that this is a right angle here. Okay, so if then this is your altitude, then that will also be the base and the altitude of your parallelogram, and in addition that will also be the base and altitude of your rectangle. So the area is length times width, base times height. Okay, and then the triangle area is half of that, and that's why triangle area is 1/2 BH. You can always construct two copies of any given triangle, because the angles will always correspond, into a parallelogram, which you then change into a rectangle. The dimensions of the rectangle will always be base of the triangle times an altitude of the times the altitude of the corresponding altitude of the triangle. Okay, the altitude that corresponds to the base, the altitude that makes a right angle with that base. So the triangle always has area 1/2 base times altitude.